Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at binomial expansions. They're called binomials because we'll have two terms in each set of brackets and we will look at expanding them. We're going to find an equivalent expression to this that has no brackets. So the idea is we need to multiply everything in the first bracket by everything in the second bracket. So this acronym FOIL allows you to keep track of what you're multiplying by what. So we start off with F. We multiply the things that occur first in each bracket. So 2x times 4x is 8x squared. Then we go O is outside, the thing on the outside of each bracket, 2x times 1. Then I insides is -3 times 4x, which is -12x, and finally we have last, the thing that occurs last in each bracket. In this case, -3 times 1. So here we have two like terms, 2x and -12x. Note that this and this are not like terms. This has two x's, this one doesn't. Only these are the like terms. So we're going to leave the 8x squared alone. 2x minus 12x is -10x, and we're going to leave the -3 alone because it has no like terms. This is our final answer. All right, let's look at x minus 9 squared. So, of course, when you square something, you're timesing it by itself. So this is the same as x minus 9 times x minus 9. So using FOIL, the thing first in each bracket, x times x. Outsides, x times -9. Insides is -9 times x. And then last, -9 times -9. Once again, we have two like terms. We'll collect like terms. We get x squared minus 18x plus 81. Now, you might notice a quick way to do perfect binomial squares. Square the first. Square the second. Note the square of a negative is always positive. And in the middle, this is the term people often forget, it is 2 times first term times second term. 2 times x times -9 gave me the middle term. All right, let's now look at binomial expansions for higher powers than 2. So we're going to look at expanding brackets like these. Now, to do this quickly, we need Pascal's triangle. So let's construct Pascal's triangle. So it starts with a 1 at the top, and then the next row has two 1s. So when you're doing any row from now on, you always start with the 1. Now, what goes in the middle of these two is their sum. So 1 plus 1 is 2. And then we always end with a 1. The next row would be 1. 1 plus 2 is 3. 2 plus 1 is 3. And 1. And similarly for row 4, it would be a 1. 1 plus 3. 3 plus 3 goes in the middle. 3 plus 1. And it ends with a 1. So note that Pascal's triangle starts at row 0 and also starts each row with entry 0. So this is row 4, entry 0, 1, 2, 3, 4. So for the row n, entry number 1 is always n. For row 3, entry 1 is 3 because this is entry 0. For row 2, entry 1 is 2. This is entry 0. So how does this help us with binomial expansions like these? Well, it turns out it's going to give us the coefficients. See, when I want to multiply x plus 4 to the power of 3, I can do this. I can start with the first thing raised to the power, in this case 3, and then the second thing I'm going to raise to the power of 0. So each term as I go along, I'm going to decrease the power of x, decrease the power of the first thing, and increase the power of the second thing. Then I'm going to decrease the power of the first thing, increase the power of the second thing, and then decrease the power of the first thing, increase the power of the second thing. Okay, now what does this have to do with Pascal's triangle? Well, each of these terms needs a coefficient and we read them straight off the row of Pascal's triangle. So when we're raising to the power of 3, we go to row 3 of Pascal's triangle. 1, 3, 3, 1. So if you do things in the right order, as I did there, you can just write in the coefficients from the row. 1, 3, 3, 1. So let's make this a little easier to work with. So 4 to the power of 0, anything to the power of 0 is just 1. So the first term's x cubed. The second term is going to be 3 times 4 to the power of 1, which is 12, so 12x squared. Next term is going to be 3 times 4 squared is 48. And then finally, the last term is 1 times x power 0 is also 1 times 64. 1 times 1 times 64 is obviously 64. There we have it. We have expanded these brackets easily. So let's now look at 3x minus 2 to the power of 4. I'm going to use the same process as last time. So what I'm going to do is take the first thing in the bracket and raise it to the power outside the brackets, and start with the second thing, which is -2, not 2, raise it to the power of 0. Then with each subsequent term, I'm going to decrease the power of the first term, increase the power of the second term. Each time I'm going to decrease the power of the first term, increase the power of the second term, and so on. So notice that for each term, the powers must add up to 4, the power outside the brackets. Okay, so Pascal's triangle tells us the coefficients that need to go in front of each term. So because it's the power of 4, we go to row 4 in Pascal's triangle. The numbers in row 4 are 1, 4, 6, 4, 1. Okay, let's now simplify this. So 3 to the power of 4 is 81. So we have 81x to the power of 4. Remember, anything to the power of 0 is 1. So the next term is going to be 4 times 3 cubed, 108, times -2. So it's going to be -216x cubed. Next term, 6 times 3 squared, 6 times 9 is 54, times, this will be positive 4. So it'll also be 216, but this time positive. All right, next term. 4 times 3 is 12, times -8 is -96. And for the final term, we have -2 to the power of 4, which is positive 16. Here we have our final answer using Pascal's triangle. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.